Hi, I'm Doyle Bishop with Tulsa Heaters Midstream. On this channel, you can expect to hear about all things related to process heating, but sometimes the topics aren't technical, but most of the time they are, so thanks for joining. Hi, I'm Doyle Bishop with Tulsa Heaters Midstream. Today I want to talk to you about draft, which is a word that we use to describe how we get air into a heater. There's different ways of doing it, and I want to educate you on what might be the best way for you to do that. Let's talk about natural draft to start with. Natural draft is this guy, and it simply uses the buoyancy effect of heated air. Inside of this heater, I've got heated air or flue gas that might be at an average temperature of, let's say, 1500 degrees. At 1500 degrees, the density of that gas is much, much lower than the density of the air outside. As I have elevation change, let's say 100 feet, the atmospheric pressure here is different than the atmospheric pressure at this location. Obviously at the base is higher than the atmospheric pressure here. So I have two different pressures acting on this buoyant gas. Think of a hot air balloon. I've got higher pressure acting on this gas down here and lower pressure acting on this gas here simply because I have this height. Think of a swimming pool. The top of the water, you go in, you don't feel it on your ears, you dive down to the bottom, you're really feeling that pressure on your ears at the bottom of the pool. Air's no different. What that does to your ears, that's difference in air pressure. And that's how draft is created, is having a different atmospheric pressure due to this elevation change. I put in this low density gas that's at 1500 degrees, and I have this force that's wanting to push the air. Most people think of it, hey, it's sucking in air at the bottom of the heater. Let me erase some of this because it's a little cluttered. And so to get natural draft, you have to have heated air, flue gas, and I have to have a stack or elevation. I have to have a change in elevation from the top to the bottom. Why would you want natural draft? One is hey, I don't have an operating piece of equipment or rotating piece of equipment, i.e. a fan that potentially could break down. And also I'm not spending blower horsepower to do that. The downside is I have to have a very tall structure, typically something that might be 100 feet tall. So I have a lot of steel to get that natural draft that I need to operate this burner. Besides just pulling the air in, for a burner to work correctly, I need to have a high velocity at that burner mixing point. To get a high velocity, I need to have high draft, I need to have pressure drop. So the air can't just simply ooze in and we have a great flame, a great burner operation, and the ability to get down to 15% excess air. So I have to have an appreciable amount of draft to get the mixing that I need to have a proper flame in this heater. So you end up with a tall heater typically for natural draft. So someone said, hey, well, how can we make this heater smaller? What can we do? We can add a blower. This is a blower symbol here. And we can do force draft, and we can make this heater a lot shorter because I don't have to have all that elevation change. The work is done with this blower. I can get the acceleration, the pressure drop that I need for the mixing on the burner with this blower, and I can push the flue gas through the heater with the blower. That's force draft. Most of all the packaged heaters that I'm familiar with use a force draft orientation with a combustion air blower. Makes the heater smaller and the capital cost is less. So there's a big driver for that. There's another driver that comes with use of a blower. And let's look what that looks like in something that we would supply. The other reason that I like a blower versus natural draft is you can see this system out here. This is the burner management system. This is what delivers fuel gas to the burner. And there's a lot of safety systems that are built into that burner management system that we've talked about before. One of the safety systems is a purge sequence, meaning before you would inject fuel gas into this heater, before you want to spark that pilot to introduce an ignition source, you want to make sure that everything's cleared out, that there is no gases inside of here mixed in with the air. Otherwise, you could have an explosion on the heater. In a natural draft heater, that becomes a little bit difficult. How do I ensure that there's no gas that has leaked through my burner management systems and gotten into that heater before I spark that pilot? Well, I can positively assure that with a forced draft blower. I can turn this blower on and I push all the air that's in this, and if there's any gas that has leaked through the system, I'm pushing it all out of this heater before I spark this pilot. So it's a great safety feature to have a forced draft operation. With that said, some folks will come in here on a natural draft heater and put a small blower on the side, a purge air blower. The downside to that is this purge air blower is pretty small and it's going to come up here and it may stratify. I could have a zone inside this heater that never really gets pushed out with this tiny purge air blower. It's okay, it's just not the same as having a giant blower like we have here that pushes everything out, that you get fully developed flow in here and pushes everything out. I like the forced draft for that purge reason. The other thing that you get with a forced draft is you get the ability to have really fine air-fuel ratio control. In a natural draft situation, I'm stuck with having to use a stack damper, and usually in combination with burner registers. This stack damper being automated, I don't have very much pressure drop to deal with, so my ability to have very fine-tuned over a wide range of fuel and air control is really limited with natural draft, whereas forced draft, I've got plenty of pressure drop, plenty of motive force, and I can simply speed up or slow down this forced draft fan with a VFD. Makes process control on the air fuel side really, really easy. These other two I just have on here just to introduce them. You don't see them much. Induced draft, very seldom. Balanced draft, the only time you see balanced draft typically is if I have an air preheater exchanger in conjunction with my process heating. In the gas plant midstream world, these are the two that you're going to see most: natural draft and forced draft. So the takeaway is we recommend forced draft for lower capital cost and for purge safety. Hey, thanks for joining. If you enjoyed this episode, hit like or subscribe to get more information about process heating and Tulsa Heaters Midstream.